Hello everyone. Let's continue our discussion for JEE Mains 2021 paper, August 26 morning, concept explanation with solution. So the next question is, in a photoelectric experiment, UV light of wavelength, so it's given you that the wavelength of light is 280 nanometer, is incident on a lithium target of work function. So work function of lithium is taken as 2.5 electron volt. If the wavelength of incident light is switched to 400 nanometers, so that means you have to deal two cases. In second case, the wavelength has been switched to 400 nanometer. Although the material is same, so work function remains same as 2.5 electron volt. What will be the change in stopping potential? So let's take the initial stopping potential as V1 in first case and stopping potential in second case as V2. So according to Einstein equations of photoelectric effect, we can write that the energy incident, that will be Sc by lambda, should be equals to work function plus maximum possible kinetic energy of the electron. That means EV naught. We can write mathematically Sc as 1240 electron volt nanometer divided by the wavelength is given you as 280 nanometer. So nanometer cancel, 0 0. So 28 by 124 is 31 by 7. So uh, that will be roughly 4.4. That will be roughly 4.4 electron volt should be equals to work function is given as 2.5 electron volt plus EV naught. So we can say that EV naught is equals to 4.4 minus 2.5 electron volt, that will be like roughly 1.9 electron volts. So V1, that will be the stopping potential in first case is 1.9 electron volt. That's equation number 1. In second case, when the wavelength is used as 400 nanometer, again applying the equation of Einstein's equation of photoelectric effect, Sc by lambda 2 is equals to 5 plus EV2, and we can write Sc can also be written as again as 140 electron volt nanometer divided by wavelength here is 400 nanometer plus work function is 2.5 electron volt plus EV2. Now if I divide this, nanometer net only cancel, this is 0 and this will 12.4. So this will be roughly 3.1 minus 2.1 electron volt will be equals to EV2. Then EV2 will be equals to zero point 0.6 electron volt. So the difference or the change in stopping potential, so the change in stopping potential, that is V1 minus V2, that is V1 minus V2 is actually equals to 1.3 volt, and that will be the answer. Let's move to the next question. Given you that in the given circuit the EMF of a cell is 2.2 volt and internal resistance is zero point 0.6, what will be the power dissipated by the whole circuit? So we have to redraw the circuit so that we can understand which one of the resistance is in series or parallel. Let's name this point already named as A. So this is also A. This is also A. B. This is also A. And this is also B. Let's redraw the circuit and take A and B as the two terminals, and it is connected to an external battery of 2.2 volt and internal resistance of zero point 0.6 ohm. So let's take the resistance 4 ohm that is connected to AB. So 4 ohm is itself connected to AB. Again 8 ohm is connected to AB. Again 8 ohm is also connected to AB. The next one is 2 ohm and 4 ohm together is connected to AB. That means they will combine in a series and will become 6 ohm connected to AB. And the another one is 4 and 8 itself is connected to AB, and they will combine together and form as 12 ohm is connected to AB. All these four resistances are in parallel, so you can say that the equivalent resistance will be equals to, so 1 by R equivalent will be equals to 1 by 6 plus 1 by 8 plus 1 by 4 plus 1 by 12, as they are all in parallel. So R equivalent, external resistance equivalent, will be equals to, we should have to take the LCM, so the LCM will be for this is 24. 6 4s are 24, 3 plus 6 plus 2. So R equivalent will become 25 by 15 ohm. That will be roughly like 8 by 3, that is 8 by 5, that is 1.6 ohm. And so this will be the external resistance. So what will be the current drawn by battery? Current drawn by battery will be equals to, so current drawn by battery will be equals to voltage of the battery divided by R equivalent plus internal resistance equivalent. So there is an internal resistance of 0.6 ohm, so it will become 2.2 divided by 1.6 plus 0.6 will give you again 2.2. So the current drawn is 1 ampere. This will be the 1 ampere will be the total current drawn by the external circuit, and you need to calculate the total power dissipated by the circuit. We already made this all the components as single resistance that will be equals to 1.6 ohm, and we have on a battery of 2.2 volt, and there will be internal resistance of 0.6 ohm. They all together makes a current of 1 ampere through the circuit. The total power will be equals to, it's a DC supply, so it should be I square R total, and I square is 1 square and R total is 2.2 ohm. So the power dissipation total will be 2.2 watt. That should be the answer. So let's move to the next question. A solid metal sphere of radius r and having charge q is enclosed inside a concentric spherical shell of radius a and b. So first thing is given you as is a solid metallic sphere. So itself is a metallic sphere. That also means the charge is only on the surface of this sphere, and the charge is given you as q. So q amount of charge. That means the positive charge is only on the surface of this sphere, and the radius of this sphere is r. Another thing is given to us is the inner radius of the shell. So we have a shell. In that case, the inner radius of the shell is A, another shell is there, and the outer radius of this shell is B. So we have an outer radius of the shell is also as B. This is also metallic, so it's also given you as metallic shell. So the all the charges on this case is also on the outside of the on the periphery of the surfaces. If the charge here is positive, so because of induction, the charge on this side will become negative, and the charge on other side will become plus Q. But we should make sure that will be no charge or electric field inside the metallic conductor. We already know that there is no electric field, inside the metallic conductor. Yeah, basically conductor, you can see that. So there is no electric field inside the conductor. That means wherever these points are there, that means from A, at a distance of A to B, at a distance of A to B, there will be electric field will be equals to 0, and at a distance of 0 to R, also the electric field is 0 because we will be inside the spherical conductor. So in that case also the electric field will be 0. So the electric field will be 0 in both the cases, from 0 to R, as well as the electric field will be 0 from A to B. Now we have to calculate the electric field 0 from 0 from R to A. That means I am talking about this region, that is R to A. So let's take a Gaussian surface. So if I will take a Gaussian surface in this region at a distance of R, so the net charge enclosed through this Gaussian surface will be only positive Q, that is inside. So the electric field in that case will itself become positive electric field because the charge itself is positive, and you can say by Gauss's law integration E dot dA should be equals to Q, that is enclosed charge will be the positive Q by epsilon naught. So the electric field will become 4 pi x square. Let's take the Gaussian surface radius as x. So x square is equals to Q by epsilon naught. So the electric field at that region will be equals to Q by 4 pi epsilon naught into x square. And that represents a rectangular hyperbola. So for a region of this, the electric field from 0 to R, 0 to R, there is no electric field inside the shell. But after that, it will varies rectangular hyperbolically. So this way, it will be changed till. But as it reached to A, the electric field should be become zero because afterward A to B, the electric field inside will be zero. Now, for an electric field from region B to infinity, that means I am going to region B to infinity, that is further than this. In that case, what will happen is, if I will assume a Gaussian surface, the net charge in that case itself again becomes E dot dA should be equals to the net charge. So if this is positive one, this is negative, so plus q minus q will nullify, and the only the charge will left will be plus q by epsilon naught. So again the electric field came out the same version, 4 pi epsilon naught x square, and then again the distance x is from the center. So the electric field varies in this version. This is electric field at 0 to r. There is no charge inside the shell, so there is the electric field is 0 inside the shell, and at the surface the electric will suddenly shoot up, and it will go like, according to Gauss's law, from A to B there is no electric field, so the result should be 0 as we are inside the metallic shell. And further if we will go, then the electric will suddenly shoot up and again obeys the same law, and the answer will be this. So the answer for this will be the first one. Next, move to the question number is the RMS speed of a molecules of hydrogen and oxygen and carbon dioxide at the same temperature is this. So what will be the ratio of them? Yeah, what will arrange them in their increasing or decreasing order. So we already know the RMS velocity is given as under root 3 RT by molecular mass. So the gas whose molecular mass, the heavier gas will have less RMS velocity. So which one is heavier? So we are talking about hydrogen. Hydrogen will be 2 molecular mass. Oxygen molecular mass will be 32. And carbon dioxide. So carbon dioxide molecular mass will be CO2. So we have to write carbon dioxide as CO2. So its molecular mass will be, we have to add like C carbon molecular mass plus oxygen, it will be roughly like 44. You know? So the highest molecular mass is for carbon dioxide, so it will have less RMS velocity. So the minimum is for carbon dioxide and the maximum is for hydrogen. So the answer will be the first one. Next question. In a screw gauge, fifth division of a circular scale coincides with a reference line when the ratchet is closed. Ratchet is closed means you have already closed the ratchet. That means there is no reading taken till now. So this is he is talking about he is talking about he is talking about the zero error. So zero error is actually equals to 5 divisions on circular scale. 5 divisions on circular scale, because till now we haven't measured any part. So zero error will be equals to 5 divisions on circular scale. So we have other things are given as there are 50 divisions on a circular scale, and the main scale moves by this on a complete rotation. The distance covered by a main scale in complete rotation is called as pitch, and pitch is given you as 0.5 mm, and the total number of divisions that is given to you is equals to 50 divisions. So in that case, you can say that the least count that will be equals to pitch divided by the number of divisions, that will be equals to pitch is 0.5 mm divided by the number of division is 50. So 0.5 and 5 is cancelled. So this will become point, that is 0.01 mm will be the least count. For a particular reading, for a particular observation or the reading, it's given you that the reading of a main scale is 5 mm. So the main scale reading MSR is equals to 5 mm, and the fifth division of a circular scale coincides with the reference line. That means he has given you LSR. That means circular scale coincides The circular scale coincides will be equals to 20 divisions. The final reading will be equals to MSR plus circle n into n is a circular scale coincides into least count plus or minus zero error. Basically, we will use according to NCERT as minus zero error. And this is actually a positive zero error. So this will be a positive zero error. So we have to calculate the final reading. So we can calculate MSR is 5 mm plus least count. Least count here is sorry, number of division coincides is 20, and the least count we have already calculated is 0.01 mm minus zero error is 5 into 0.01 mm, because the zero error given in is given in a divisions and you have to convert it into the linear distance. So 5 mm plus 20 minus 5 is 15 into 0.01 mm, then the result will be 5.15 mm, and this will be the final reading and answer for this question. The next, so thank you everyone for this. Please subscribe for more content. Our YouTube channel is there, sapienseducation.com, and you can also visit us as Meta as well as Instagram link given below. Have a nice day. Take care. Keep smiling. Bye everyone.